This is also fairly short. And it's also, it's good knowledge to have all this stuff for anybody interested in these kind of issues. All right, so we'll go over kind of the difference between training, right, aerobic versus anaerobic. We'll see what happens during certain types of training, how you can kind of switch. Right, despite your genetics and everything, there's some plasticity in the muscles. They can switch from one type to another. Talk about after exercising, why you need to recover a lot of the oxygen, just different from the amount you're using during it. And then we'll talk about muscle growth, right? Losing muscle, gaining muscle, and then how muscle can grow, and when you get damage to muscle, how do you actually repair it, and then the aging and disorder stuff. All right, so aerobic versus anaerobic training, right? Running, jogging, marathon running is aerobic type of stuff. Aerobics, right? That's the name of that kind of exercise where you're in an aerobics class, or versus when you're doing powerlifting or something like that, right? So this would be a very, if you're doing some kind of, deadlift or snatch or something like that, right? It's going to be a very quick burst of really powerful energy. You're going to be kind of putting everything you can into one lift, right? That's going to kind of activate those big motor units and all that, those fast glycolytic fibers, all your white meat, those big muscles. Whereas this, you can run for 25 miles, right? And well, I can't run for 25 miles. I can run for longer than I can lift this weight. Let's put it that way, but that's about it. But you can walk in for hours, right? You could do this for about a second. And, going back to this, right? There's fast twitch motor units, slow twitch motor units, and within a single motor unit is activating all the same type. So again, this is an inherited predominantly, right? If you've ever heard of like Kenyan runners, they always win the marathons and stuff. They just come from this, genetics or something about where they live or something. They're just really good at marathon running. And you can tell by their legs versus, I don't know who's really good at weightlifting and stuff, but it would be definitely a different body type. But if you are somewhere in between, especially, you can do a lot of running and aerobics and stuff, and you can kind of switch over to this slow twitch muscle fiber, like more aerobic, more, you're going to increase your vascularization, right? You're going to increase the number of mitochondria, you're going to increase the number of myoglobin within there, and this will give you much longer, you can last a lot longer, whatever you're doing right there by doing this aerobic training. Great cardiovascular training right there. Or if you go down and power lift, right, do these big bursts of energy, right, you can take those intermediate type of fibers and shift them a little bit over there, right? Make them, you're going to pack, they'll become bigger. Typically, this is when you start to grow muscle, as opposed to here, right? These guys are very muscular, but their muscles aren't huge, right? Whereas these guys can get very big. And this is all due to, building actual muscle protein, the myosin and actin over there, right? But they'll shift over to that and you'll become fast twitch and utilize that whole method more. Right, so this is anaerobic versus aerobic training. And this is really key here, right? You're getting much healthier vascularization, mitochondria, myoglobin. Your muscles aren't really getting bigger, right? They might be getting more toned and everything like that, but they're not really getting bigger. So, oh yeah, here's the Kenyan runners, right? These guys, their legs and everything, they're just really built for this. And also, I want to ask you guys, can you recognize any of the muscles here? What would be this muscle? This is a really well-defined one. You don't usually see it like that. It's that one that goes from the lateral side to the medial side, but it's actually the sartorius muscle. Remember that thin strap that goes around, like it goes from the lateral, like from your iliac spine over here, and it straps right across the front of your leg like this to the medial side. That's just a nice, that's usually you don't really see those too easy. Right there, kind of sticking out like that. But then this would be the vastus lateralis, right? Your quads right there. This would be your gastrocnemius. This would be your soleus right there. So those are people with a lot. They can just, and so, but other people. So talking about switching, you have some genetics, right? This is me over here. I don't want to get bald, but that's me over here. After I started training, this was me before. So I switched a little bit after working out somewhat, right? But obviously, like you could see, all right, there's a deltoid, but then it gets a little funny, maybe there's the pecs, right? But there's obviously a huge difference in the size of these muscles right here, right? And probably this guy's got very different genetics than this guy. So when we're talking about strength training, right, and training and exercising and changing muscles and stuff, right? I want to also mention as maybe more of a public service announcement, right? Just some of the benefits of actually, instead of just aerobics, which is great too. People kind of underestimate weight training. You're not really necessarily trying to look like that dude over there, right? You're just building overall muscle, right? And so you're using progressively heavier resistance. That's really the biggest point in it, right? And you're doing things that are going to give your whole body strength over there, like squats and deadlift are really the best things for building overall strength, not really getting like huge biceps or something like that. But when you do those, right, more muscle mass you have, the more your resting metabolic rate is, right? The amount of energy you're burning, even when you're not working out. So you can eat a lot more food, like burn more calories because you need more to maintain that resting rate. And also, if you're doing everything right, and when you're doing it right, see her back right here? She's flexing at the hip over here, but her back, her vertebral column right there is totally straight, right? It's not flexing at all. It's totally extended, right, in anatomical position. This guy's back, see this curvature right here? That's a little bit of a spinal flexion, right? So that is not good for your back. I'm sure he's going to straighten out, but that's how you want to be, right? So you're doing these deadlifts. And once you start doing these, you learn, how to lift heavy weights. You learn how to like brace yourself, brace your core and everything. And it really helps you prevent back injuries. Because I'm going to tell you, when you get older, you can, do all this stuff and everything, but one day you'll like reach over to pick up your cat and you'll totally throw out your back for totally unknown reasons. And the more you train yourself to kind of brace yourself anytime you're lifting any kind of load, the safer your back is going to be. So there's all the whole things of also just relieving some energy, like stress and fatigue, especially these days when it's all crazy. And then the other thing is, I talked about this when we talked about bone density, losing bone, osteoporosis, right? Your general, as you get older, you start to lose bone, right? When you're doing these very, weight bearing loads, you also increase your bone density. So the more you have, when you start to lose it, the longer they'll last, right? So all these things are good about strength training. And it's not like trying to look like that guy over there, right? It's just really about getting overall strength. That picture of me. All right, so now, when you're doing all this weightlifting, you're doing all this resistance training and stuff like that, you're recruiting. In this picture, I kind of put it in, right? Low weight, higher weight, higher weight. When you're doing this kind of weight, you're burning a lot of calories, right? And you're burning because you're using a lot of ATP, right? This would require a lot of stimulation, which would require a lot of sodium potassium pump to maintain this gradient, a lot of calcium, ATPase pump to maintain low, high intrasarcoplasmic reticulum levels of calcium, low on the outside. And of course, the ATP used in this whole myosin actin interaction. You're using up a lot of ATP in all this, even if you're not using oxygen in this one thing, right? You're going to be using a lot of ATP in any kind of exercise you do. So I just want to mention for afterwards, you're using a lot of ATP, and you obviously, when you're doing all this stuff, you're breathing heavy. And if you do like some kind of heavy lifting weights, you'll notice right? I'm not lifting weights anymore. Why am I still breathing? In fact, I was doing all these things that didn't even require oxygen, supposedly. So why am I having to breathe so heavy, which indicates my body thinks I need oxygen, right? So this is for a couple different reasons, right? But the general term for this is, oxygen debt, or the book I think says recovery oxygen uptake is a better term, but this is going to refer to that added oxygen above resting oxygen consumption that's taken into the body after exercise, right? And so the things that oxygen is needed for is, remember, all that lactic acid that was built up in the muscle, right? That's going to be transported in the blood into the liver, and then you can convert that back into the glycogen, right? That glucose storage polysaccharide molecule that's in the liver. So that's going to take energy, right? Anytime we say oxygen, we're talking about doing that whole oxidative phosphorylation, right? So to do this takes oxygen. You want to resynthesize that creatine phosphate as well as the ATP, bring it back to storage. Also going to take energy, right? It always takes energy so that you have readily available energy when you need it. And then you also want to replace the oxygen that you used up for myoglobin, right? So you're breathing heavy for quite a while after you do these. Plus, and this is all the reason why, this burns a lot of calories actually. You start to heat up. This is going to, when you heat up, you're increasing all your enzymatic activity inside your cells. So it's going to increase the rate of chemical reactions. So your heart is pumping faster to move blood around to do all this. Your diaphragm and your intercostal muscles, right, which are your skeletal muscles used in breathing, are using all that ATP to do their work. So they're still working hard just to keep up this oxygen debt, right? So it's a continuous kind of thing. And then if you do, stimulate, if you do enough work, right, so that you actually irritate, or you kind of do a little bit of tissue damage, a little bit when you're doing that working out, which is, what you have to do to actually build muscle. Right? So all these are happening, and that's why you are breathing heavy afterwards. And so one of the reasons I mentioned this, just to come back to a lot of this stuff, right? Just to remind everybody: lactic acid, creatine phosphate, myoglobin, all that stuff. All right. So that's just a little side note. And now we're getting to this next subject.